Hello everybody, Lance here. Welcome to another video tutorial of Blender 2.8 Basics. And in this video tutorial I'm going to show you the properties of the Cycles render engine as well as the properties of the camera. By the end of this tutorial you will be able to improve this rendering, which is the result of the last video, and improve it to something like this. Okay, so let's get started. So this is where we left off in the last video. Go ahead and go to the rendering tab and make sure that Cycles is the current render engine. Otherwise the options down here will look different. Okay, so make sure that Cycles is the render engine. And first things first, this is the dimensions. And here you can tweak the resolution for the render image. And currently it is set to 1920 by 1080. This is full HD image. And here we have the scale for the resolution. For example, we can scale down the resolution by 50%. The rendered image will be smaller by 50%. So yeah, let's set it back to 100. And we can just ignore the rest of the options here for the time being and close the dimensions. Here we have the output. Here you can set the path to the place where you want to save your file, and here you can specify the different kind of files you want to save, and the option for whatever file format you chose. Okay, so let's go ahead and close that as well. Metadata, stereo copy, freestyle, these three you can just ignore for now. Okay, next we have the sampling. Open it up and we see that here we have two different integrator, and path tracing is faster for simple scenes like this one, and branched path tracing is faster for complex scenes with very complex materials. So for the time being, let's choose path tracing. And here we have two different numbers. And basically this is the number of rays per pixels that will be shoot from the camera. The render number will be used when you go to the render and render image. The hotkey is F12, and the viewport number will be used here right in the viewport. So currently the viewport is tracing 32 rays per pixel. Okay, so if we zoom in and let's hit Ctrl B and select a region to render just that region so that we can save a little bit of render time. Okay, so here you can see that we have a lot of noises. This is because 32 rays per pixel is not enough to generate a high quality image. In order to reduce the noise by 50%, we need to double the number of rays. However, if we double the number of rays, the render time will also be double. Okay, so let's go ahead and double this number until we find the noise to be acceptable. Right now at 128 we still see a lot of noise in the shadow area, so let's go ahead and increase the render time again. Alright, it's getting better. However, I still don't like the noise here. And let's go ahead and double it again to reduce the noise by 50% yet again. 512, and let's wait for the render. There we go. However, I still don't like the noise here, so let's go ahead and double it again to 1024. And I think 1024 is good enough. Okay, it is indeed good enough. So I'm going to set the render to be 1024 and set the number in the viewport back to 32. Okay, so that is how you increase the quality of the render engine. Okay, next down here we have light. Here you can see the maximum amount of the maximum brightness for the light. 0 mean unlimited. So currently the direct light will be unlimited. That means if I set this light to something like 1,000,000 or something like that, we will have a burnt out kind of image. However, if I limit the brightness of the direct light to something like 10, we get something much better. Okay, so let's go ahead and set it back to 0 so that we have something like this. And we're going to set the light back to 5000 and hit 0 on the numpad again to go back to the camera view, and Control B again, and now select the entire teapot. So that is how you set the quality for the rendering. We can go ahead and ignore geometry for the time being. The next thing you need to pay attention to is the light path. Here you can specify the amount of bounces to trace per light path. So if I set this to 0, I get no bounce light at all. This part down here, this is being illuminated by the bounce light from the floor. So right now there is no bounce light, so we see pitch black in here. Or maybe just a little bit of light that somehow get directly illuminated by the light up here. So let's go ahead and set this to 1, which is a little bit better. However, we still see a lot of black down here. That is because this area here is being illuminated by the light that bounce off the teapot from up here. This means that we need at least 2 bounces. So this is what 2 bounces gets us. So let's see what 3 gives us. Essentially, 3 bounces give us no difference at all. So we are going to set it to 2 bounces. So the more bounces that you have, the slower it will get, obviously. So 2 bounces is enough for this particular scene. And we have a lot faster render. So let's go ahead and measure the time. This is 0.49 seconds for this particular spot. So let's go ahead and hit Control B and drag across the entire render region. Okay, so the render time is 0.54, and let's go ahead and render again. And again we have something similar. So let's go ahead and set this to 12 again and see how long it gets. See, it's going to be slower, and the more complex the scene is, the slower it will get. Always set the bounce light to be as slow as possible. Okay, so that's it for the light path. You don't have to worry about these for the time being. We are going to touch these later, because these are very, very technical, and right now I'm sure you don't want to bother with the technical side of things. So yeah, let's go ahead and close the light path. And the last thing you want to notice about the render engine is the performance. Here I am rendering using my GPU, which is the NVIDIA 1070, so it's pretty fast. And by default it is going to be CPU, which is much slower. As you can see here, the rendering is very slow, and it takes over 6 seconds to render this teapot. Okay, so let's switch back to GPU, and as you can see, the render time is 0.5 seconds. So yeah, and another thing that you should notice is the tile size here. This is the size of the tile that will be in the final render. Currently in the viewport, the entire image is being rendered at once, but during the render time, if I hit F12, you can see that we have a tile that rendered the image. And this is okay, let me just hit escape to cancel the render. So this is where you set the size for that render tile. For GPU, you might want to increase this tile size, but for CPU render, you might want to decrease the tile size. Okay, so currently I'm using the 1070, and I have been experimenting with the tile size, and I find 400 to be the best size. Smaller than 400, the rendering will be slower, and for larger than 400, the rendering will also be slower. However, for CPU, I find 32 by 32 will give me the best speed. So yeah, let's go ahead and set this back to 400 and 400 and switch this to GPU. Okay, I almost forgot. If you have a graphics card installed and the GPU option is grayed out, then you can go to Edit and go to User Preference and go to System. Here you can then turn on CUDA, or if you use AMD graphics card, then you can turn on OpenCL. Okay, so let's close that. So that's all the options that you need to memorize about the render engine. Next, we will have a look at the options of the camera itself. So 3D rendering is just like virtual photography, and very similar to the reality. We need to tweak the virtual camera, similar to the way how we tweak the camera in reality. So let's go ahead and select the camera, and here we have a camera tab, and here we have the options for the lens and for the camera itself, and the depth of field and stuff. So you can just ignore the viewport display, save area, and background image and stuff. And we're going to focus on the lens, the camera, and the depth of field for the time being. So first things first, the lens. Open up the lens, and here we see that we have different type of camera. We have perspective camera, which is the physical kind of camera. We have the orthographics camera. This is pretty much the orthographics view, and it's similar to the hit 5 on the numpad. And yeah, this is the orthographics view, and all the depth information will be lost in this view. Okay, so if I am to duplicate the teapot and move it far away from the camera, you can see that the teapot still have the same size in the camera view. Okay, so let me go ahead and delete the teapot. Select the camera and set it to perspective again. Oh, and panoramic camera. This is a special kind of camera that is very weird. For example, we have fisheye kind of camera, and we have mirrorball and equirectangular and stuff. So this is a very weird camera that is useful for very specific cases. But for the time being, let's switch back to perspective mode. Perspective type of camera. Next we have focal length, and this is similar to DSLR camera in reality. We can specify the focal length to dictate the field of view, and if we decrease the lens we have a wider view, and if we increase the lens we have narrower view, and if we increase this too much, the view is going to be somewhat similar to orthographics. Okay, so let's go ahead and set it to be something like 50mm. You can also set this to field of view, and here instead of specifying the focal length, we can specify the field of view by degree. Here we have the shift, and I don't know if any of you are going to use this shift value, but anyway, I find this shift to be quite useless. And here we have the clip start and clip end. So the clip start, that means that anything that is closer than this distance, it will not be rendered, and anything that is further away than this end distance, it will also not be rendered. For example, if I increase this clipping to something like this, and suddenly the teapot is not getting rendered anymore. Okay, so let's go ahead and decrease that to something like 1 centimeter. Okay, and the end clip, let's go ahead and set it to something like 1 meter, and I think it is too close, so there we go. So yeah, that is what the clipping does. So let's go ahead and set it back to 1 kilometer. Okay, so that's about the lens. Next we have the camera section. Basically what it does here is setting the sensor size for the camera, and like in reality, the virtual camera also have a sensor size. For the DSLR in real life, 36 or 32 may be the standard. For a phone kind of camera, 4mm will be the standard. And if you set this to something small, you have to set the focal length to something small as well in order to have a proper field of view, something like so. Let's go ahead and set this back to 36, which is the default, and set this to 50 millimeters. Okay, so let's go ahead and close it. And the last part, which is the most interesting part, the depth of field. Right now everything is perfectly clear. The closer part and the further part, everything is perfectly clear. Let me just create, say, a monkey face, and let me just scale it a little bit and move it closer to the camera. And we can see that the monkey face is very close to the camera, and the details are perfectly clear. And it doesn't matter how close or how far away the objects may be, it's always perfectly clear. And this is not realistic because real camera has a depth of field. The depth of field is basically the distance in which the objects appear to be clear. And outside of that distance, the further away from that distance, the more blurry everything will become. So in order to make it realistic, we need to add depth of field. So select the camera, and here have a look at the distance. Right now the focus distance is 0 meter, which means that there is no focus. I can set this to something like 1 meter, and here I can set the size for the aperture something different than 0, otherwise everything will be perfectly clear. So let's set it to something like 0.01, and suddenly anything that is close at 1 meter range will be clear, and anything that is outside of 1 meter range is going to be very blurry. For example, if I move the monkey face closer to the camera, you can see that it is not clear. It is blurry, right? And if I move it closer to the 1 meter focus point, it suddenly becomes clear again. So as you can see, it's very hard to set the depth of field correctly this way. So there is another way to set the depth of field. Let me just go ahead and delete the monkey face and select the camera. Here we can see that we can specify a focus object. For example, I can specify any object that already exists within the scene. And currently this teapot doesn't have any name, and its name is cylinder, because we created from a cylinder earlier. So let's select the camera, and here we select cylinder, and now the camera is focusing on the pivot of the teapot, which is this little dot here. And right now the teapot is huge, and it's like 8 meters away from the camera, so the depth of field is going to be quite large, and we need to bring stuff very far away from this field from this distance in order to make it a little bit blurry. So let me duplicate the teapot and move it closer to the camera, and GZ to bring it up a little bit, and we can see that the front teapot is now very blurry. Okay. However, right now the camera is focusing on the pivot of the teapot. What if I want to focus on the surface of the teapot? So we need a way to specify a perfect distance, a precise distance, and focus on the very surface of the teapot. So in order to do that, first we need to click on the teapot, and right now the 3D cursor is on the surface of the teapot, and now we can hit Shift A to bring up the add menu and go to empty and create a plane axis. This is an empty object. This object does not render, and it simply specify a position in 3D space, and we can make it a little bit smaller, something like that. And now we can use this particular empty as the focal point for the camera. So select the camera and choose empty. So now the teapot the camera is focusing on the surface of the teapot. And now if I increase the aperture size to something like 5 centimeter, we can see that the surface of the teapot is still clear, but anything outside of that range is blurry as hell. So this is actually 5 meter aperture, which is massive. So maybe 0.05, which is 5 centimeter, and maybe 0.1, which is 1 decimeter. And we can see that the sharp edges of the teapot is still clear, and the knob of the lid is blurry. So yeah, that's how you specify the focal point for the 3D camera. Another way you can specify the aperture size is using the f-stop. If you're familiar with the DSLR cameras, you might want to use f-stop instead. So let's go ahead and set this to something like 2.4. Okay, it's the depth of field is not narrow enough. It's still too wide, so I'm going to lower this number to something like 1.2, and let's zoom in to check it. It's still very clear. That is because this distance is basically 8 meter, and it's very far away. So yeah, the depth of field is quite large. So let's go ahead and decrease this to something like 0.8 and maybe 0.6. I think that's good, but this is not a very realistic teapot because it's huge and it's very far away. So the f-stop does not do very well. So I'm going to switch back to the radius way of setting, and I'm going to maybe make it 20. Okay, so I think this depth of field is good, and I'm going to move the empty object to something around here, so that I can get the tube and the knob to be clear while the edge here is blurry. So go to the top view and hit Z to turn on the see-through mode, and maybe position it somewhere around here. The tube of the teapot is perfectly clear. Okay, so that's it for the camera setting, and the next thing is to render the new teapot. To make another render using the new setting. However, before we make the render, I'd like to get rid of these sharp edges of the teapot. Now, one way we can do that is to increase the smoothness in the subsurface modifier that we added in the last video. The more we increase it, the more it will subdivide the teapot and make smoother edges. However, I will need to divide this a lot in order to get a clear result, and it will make the rendering very slow and consume a lot of memory. So I'm going to set this back to 2 and use a different method. And this is actually a cheating technique, and it's not physically correct, but it'll look pretty good. And yeah, select the teapot and go to Object and then Shade Smooth. Okay, so if you look closely, we can see that the edges are still sharp, but the way the computer draws the surface onto the screen, it draws everything as smooth. So that's how you make a smooth surface without making too much geometry and drag down your computer. Okay, everything is ready, and for the sake of it, I'm going to add a monkey face in the back so that we have a clear sense of depth. A better sense of depth. Let's move GY to move the monkey over here, and A to deselect everything. Alt A to deselect everything. Okay, so I think we are ready to make another render. So let's hit Z to turn off the render in this viewport and go to render and render the final image. I'm going to cut the video and come back when the rendering is done. Okay, so the rendering is done, and we can see that it took 2 minutes and 48 seconds. And let's roll the mouse wheel to zoom in and take a closer look at the rendering itself. And we can see that there is still a little bit of noise down here, and yeah, basically we still have a little bit of noise, but it is quite acceptable. Basically, with a brute force render engine, you will never get rid of all the noise. You have to basically double the render time in order to get rid of 50% of the remaining noise. So if you increase the render time to infinity, you will eventually get rid of all the noise. But obviously we don't have infinite amount of time to make the render. So you just need to increase the render time until you find a point that you say it's enough. So for me, I think this is actually quite enough. And also, in reality, real image also has some noise in the dark area like this. So yeah, having a little bit of noise actually adds to the realism of the picture. Okay, so this teapot looks pretty good right now, but notice that the surface is pretty much blank, and there is no surface variation or whatever. So yeah, that's going to be the topic of the next video. That is texturing. I'll see you next time.